Good morning, good afternoon, and good evening, ladies and gentlemen. This is Glenn Tan speaking. This time we're going to talk about photovoltaic direct-driven GNV, short for PV-GNV. This presentation is based on OSIA models. The difference is the power spec and the converter. Either it is built in or together with the outdoor unit for transportation. As for the functions, they are completely the same. And this is the product lineup of all our green PV products, including the air conditioner for household use, split tie, and this is our famous PV-GMV for VRF. And also we have the rooftop. It is very popular in Middle East and Africa area. And also we have our centrifugal chiller. It is PV. And also currently we are developing this cold storage. Also we use the PV energy. Today we just focus on this PV VRF. Maybe other manufacturers also claim that they also have the PV VRF, but actually it is not that same. And here I will explain how they work. So you can find it on this graph. This is for example the regular VRF, and this is the converter. It's handling the power, either it's from AC, which is from the grid power supply, or from the DC, is from the PV panels. So for this case, this converter need to, for example, if get the power from this DC, and you need to convert this DC to AC, then power to the regular VRF. And for the complexers and fans inside, if they are DC, which is very popular, they need to convert this AC to DC again, then to drive the inside complexer and fans. So the total convert loss there are 6%. It is for 2 times. But for our PV-GMV, which is this one, so you can find it. We also have a converter, but it is built in, which means this is actually the regular VRF, and we buy them together. So on the side, you just need to connect the power from the grid power supply, which is AC, and then here is the power from the PV panels is DC. We can use the DC to drive the inside compressor and fans, so we can eliminate this 6%. And on the other hand, this can also improve the construction speed, as you don't need to set up the converter, so it's easier for you to install it. And this slide explains how this PV-GMV works. So for the mode 1 is not uploading to the grid, which means you get the power from the PV panels only for the power consumption of this PV-GMV. So for this system, first is it can consume 100% the power from the grid power supply, and this of course just acting as a regular VRF. And also it can consume the power 100% from the PV panels. And also it can mix them together, which means if here the power is not enough, we can also get the insufficient part from this grid power supply. And all these three, they are all automatically, no need to set anything. So for the mode 2 is uploading to the grid, and this require the local policy, which means the local policy, if it allow, you can upload to the grid power supply to earn some money. And for this one, first is pure PV power generation. That means if this PV GMV, which this one, is not working, so at that time, here the PV panels still generate the power, and then you can upload to the grid power supply to earn the money. And the next is the balance, which means here generate much. Then we can also power the PV GMV and also uploading. This is the perfect, right? And also for this two and also once setting, there's no need to change. And for the third is PV storage integration. That means if not allowed or you don't like to upload to the grid power supply, you have a third option, which is to stop the abandoned power to this what we call energy storage unit. So at this you can find it that is actually a transformer, which is we will lower the voltage of this DC and then stop the power to this battery. Actually for this one you can buy it from grid, or you can just prepare yourself and just follow our requirements. It's okay. And for example, in daytime you can stop the abandoned power to here, and after sunset, or if the power from the PV is not enough, you can also get the power from this. And for the fourth mode is to offer the power to other home appliance. In this case, you can find that here we stop the power at the battery, and we can offer the power from here to the other home appliance. Actually here it is auto DC, you can apply the DC to AC transformer, then you can get the AC current. Then you can power on the other home appliance, either it is DC or AC. And also for this one, we require engineering customized. For the fifth mode, it is off-grid PV system, which means at this system it is isolated from the grid, which means you can get the power 100% from the PV panel or from the power generator. At this case, you have two options, which is to first one to use this energy storage unit. We can stop the power from the PV panel and to here, and then from here we can offer to the PV GMV, and also you can offer to the PV GMV in dot units. And the other option is just to apply this power generator, and this one is similar to the grid, which the output is already AC, so we can power on this PV GMV. They can combine the DC, which is from the PV panel, and this AC together. And the next is I will introduce the core technology. For our PV GMV, there are these 5 technologies. Actually, it is a little bit complicated, and also from the name you can also find it. And actually, for this one, the power generation and consumption management, and this is just will making the power consumption and power generation to be visualized, and also this is convenient for you to analyze and management. And this PVG1 direct G1 technology, that means we can drive the inside compressor and the fan motors directly from the PV panels, which is also DC, and so we can higher the efficiency by 6 to 8%. As for this 3, the PAWN interleaving technology, multi-converting technology, and dynamic load tracking and PPT technology. The 3 of is aim to lower the PV power fluctuation. As you know that especially when it switch from the PV panels power to the AC power, which is from the grid power supply. If the tie loss is too much, it will make the compressor to stop. And for this 3 technology, we can avoid this. And next part is PV equipment selection. This is the outdoor unit for Ocean models, and here is the appearance and the capacity. You can find that it is very similar to the GMV Mini, and actually it is the GMV Mini. We just plus the PV functions, and which means the capacity is completely the same as GMV Mini. And here is the PV function, the parameter we add at this device. And here the most important is this one, the max DC input power. And also the next is the max DC open circuit voltage. This information you can find it on our service menu. We have a table the same as this one. As for the indoor units, for this part is completely the same as the regular VRF. And this is the centralized controller special for the PVGMV. And here is the model. And as for the connection quantity, it is the same as the regular VRF system. What's different is, and you can find it from here. Actually, this is very similar to the CE53, and the difference is just here. From here, it will show you the detail of the PV system. So you can find it. We already display the how much power this VRF consumes, and how much power from the PV panels, and how much we get from the grid power supply. And also these 3 icons here, you can click on it, and then it will show you the detail. The first one we will put it all in the parameter, and the next is press here. And also we can see this one. This is we make the data to be curved, which is much more convenient for you to do the analyze and also the management. And this one is another curve. And this is the centralized controller and how to do the wiring. And also similar to the C52, and here is the terminals of the C55. Here is for the power supply, and in the system for this part, it is the same as the regular VRF, and this is connected with the slave indoor unit and outdoor units. So this is the master outdoor unit. From the master outdoor unit, if there are only one system, you can connect from the D1, D2, which is from here, then connect to here, which is here, the G1, G2. And also don't forget the matching resistor to ensure the communication. This is for single system. If it is a multi-system, only from the master G1, G2, just like this, and they can combine together from here and then connect to this G1, G2. As for this F1, F2 is for the fire alarm, and once we see the fire signal, this centralized controller will stop all the online operation. And this is the energy storage unit, which it is the battery. And also you can connect with the G-IEMS system, which later I will introduce, and the purpose of it is just to stop the power. What you can do is we can adjust the electricity for the price at peak hours. That means, for example, if in your local, if the electricity fee during the daytime and nighttime is different, so we can adjust this part, which means we can stop the energy during the daytime and use it in the night. And the next is the G-IEMS system. And first is this is the topological. And for this one, and this is the PV system, which is the outdoor unit and the indoor units, and also including the PV panels. And for this one, also from the master outdoor unit from G1, G2, you need to connect to this gateway. And here is the model. And also for this system, you still need to install the power meter. One is for DC. This is to calculate or to measure how much power you get from the PV panels. And also another is from the AC. This is to measure how much power you get from the grid power supply, and if it is available, which means you can upload the power, we can also measure this part. So for this one, it is a binary, which is from and to the grid. And after that, from here, you need to connect to the server on the Ethernet cable. Then from here to a PC. So from the PC, actually it's on the west side. You can also control and check the system information. And this is the homepage of the G-IEMS system. Its function is all engineering customized, which means you can change the detail. Just contact with our salesman. And also you can check and do the management from your smartphones. And here I will just show you a project which is in Dubai. So from here you can find it when you go into this website. Here you can make a selfie to introduce what's the project, and also to this is DIY. And for this data, we make the power consumption for every day, for every month, so make it to be curved. It's better for you to do the analyze. And also you can find from here, this is the PV panels, this is the storage, the battery, and here is the how much power you consume, and here is how much power you get from the grid power supply. And also on this one is the CO2. We make it to be a CO2 animation, which is more popular. And on the other hand, you can also check and control the indoor units from this software. And from this one, from this example, you can find it. This is display how the indoor unit works. And just click one, and here is the control page. You can control the indoor unit to operate. Next part is how to do the design of the PV system. As for the cooling and heating load, it is completely the same as the regular VRF. You can just follow that to select the capacity. And here is the PV system. First, you need to check how much the solar power for your local. And here is two methods. First is you can check from the NASA website, and the other is from this software. From here, you can get the average solar power for every square. So after that, you can select the PV panels, and our grid can also offer the PV panels, and currently there are three models of it, and you can find it the size. They are the same. The difference is the max efficiency and also the power output. And when you select this one, and you need to ask the manufacturer what is the efficiency and also the power. And this is the detail of these PV panels. And for your selection, this parameter is important, which is the maximum output of this of each panel, and also this four, the max voltage and the open circuit voltage, and also these two. And this five parameter is very important for you to do the selection. After selected the PV panels, and then you need to combine them together as a string and connect this string to the PV outdoor unit. And the first step is to calculate how many panels for one string. And the formula is this one. And then the next is to calculate how many strings for one outdoor unit. And the formula is this one. And for this also you can find it. This is the P is for the max DC power of this solar outdoor unit, which we listed on the service menu. And here the PS, that means the N, this is the quantity of one string, which is this one. At the step 1 you calculated value, and this WP, that means the maximum output of this panel. And of course, for this one, for the finally you can get this string quantity. The higher of this value, that means you can connect more strings. Also means you can save more power. So I will show a detailed example to do the calculation. And also you can find it, there is we also make Excel files. This is for quick calculation only. This slide displays a detailed example for the calculation. And in this case, we already selected the outdoor unit to be this one. And on the service menu, you can get the PV parameter at this table. And just open this Excel file. It will display this page. And from here, you can find it. Here is for the PV panel information. This is for the information about the outdoor unit, which is the PV GMV. And then the later, and this one is for the local ambient temperature. After that is all automatically calculation. So from this case, here is the most important, these two. You need to follow this one to input to here. So you can find it, the max, it should be this 400, and the max MPPT is this one, and the minute MPPT 100. And then from this case, you can get it to be 9 pieces for one string. And the next is for once, how many strings we should apply. And the formula is this one. This P is the max power PV input power. It should be this one. And just put it here. And also this N is this 9, and this WP is this one. The peak power of these PV panels, of one PV panel. And also input here. Then we can get this number. It should be only two strings for one outdoor unit. And for the next part is how to do the wirings. And first, you need to decide where to install the PV panels, and which from these three, which is the best angle lighting and the flat install. And this is the also flat install. And according to different cases, in the cement flat, steel roof is best for the factories, and this is the galvanized tile roof for the household use. So for this one, this is the before and after. And also for LV square meter, how many or how much power of this one can generate, we can also write here for your reference. After we install the PV panels, next is how to do the wiring, which is to wire them together, and it is very easy if you apply this MC4 fast connection. And we just combine the minus and plus together. You can also find it in this case, we just connect here. And this MC4, after you applied it, we just make the connect the pin is like this, and then insert this pin into this one and fasten it. It is very easy. And after you connect it, please check the open circuit with the multimeter. The voltage should be at this range for one string, and the difference between two strings, the voltage it should be less than 10 volt. If the wire is more than or longer than 200 meters, please consider the resistance. And the last is the most important. We require or we recommend to periodically clean the PV panels surface to ensure the efficiency. As you can find that the surface it will accumulate the dust which will lower the PV efficiency. Next is how to do the wiring from the PV panels to the PV GNV. And at this case, it is side discharge. You can find it. For this one, we need to combine the PV panels together. And actually, it is a combined box. And for side discharge, it's no required. You just need to ensure the PV panel and also the PV GNV. You need to avoid the lining damage. It's okay. And also there is a circuit breaker just to stop the power supply from this PV panel. Either you need to do the maintenance or do the repair of the PV panels. As for the grid side, which is this one, also we require AC distribution cabinet. Actually, just a circuit breaker is okay, and also just the important is to avoid the lining damage. Here is the detail how to do the wiring from the PV panels to the outdoor unit. And the first thing first is to check the connection, which is the positive and negative. Here the plus and minus, they should follow this sequence. And then to check the isolation with the megameter to ensure the isolation. And next is just to ensure this cable is well protected. As for the detail wiring, which is connected here to here, just open this panel, you can see this one. And at these terminals, this one is for the AC from the grid, and this one is for the communication wire to the indoor units. And this here is for the DC input from the PV panels. Just plug in the PV panels into here. As for this one is for jack signal. And for jack 0 function, you need to short circuit the number 5 and number 10 of this RJ45. Next is to do the commissioning. For the commissioning is similar to the regular GNV. Here I just display the difference, which is the additional setting on the main board. And here also you can find it. Here is the steps. Just power on the indoor unit and outdoor unit. The first thing you need to select the QN, which is for the voltage on grid setting, which is this one. You need to set this one. This is to choose whether you would like to upload or not upload to the grid power. And after this one is to set the QP for the export area, and we have for Australia or for New Zealand. And after that is to initiate the commissioning. For after it is completely the same as the regular GMV. As for the maintenance, just due to the change of the outdoor ambient temperature, the humidity, and also maybe the dust situation, there for the VRF, it is almost no need to do the maintenance, but inside the converter, this is the converter, you need to do the periodical maintenance. Actually, for this converter, there are 3 layers. This is the built-in. You can see, just open the panels, and inside this one, this is the first layer. It is the power converting PCB, and also here there is a second layer. Is taking the sample PCB, and also at this part, this is the third layer, the CPU PCB. So you can find it. It is a little bit complicated, and just due to your working condition, if it is not that good, you also need to do the maintenance. And also based on the situation, which is the condition, this outdoor unit located here is our recommended period. And also if your working condition is not that good, you need maybe shorten this time. And here is the checking items. When during the on and during the VRF on, and here is how to check it. Check the damage or deformation of this converter, or is there any abnormal noise coming out or abnormal temperature rise. As for the system cleaning, just focus on the temperature and the dust on the heat sink to ensure it can release enough heat, avoid overheating. And also to clean the heat sink with the high pressure gas. And for the terminal, we recommend to check it every 1 year, including the PV input, AC input, and DC output if you have this upload to the grid power supply. Next part is the basic troubleshooting. First is how to check the code, and the code will display on these 3 devices: outdoor unit PCB, this LED, or wire controller. Here we will also display the code, and also if the inside it is the for example the cassette type, it will also display the error code on the light bulb. And here is the maintenance tools you may use during the maintenance, including the multimeter, the current meter, and also screwdriver, and this is the mega meter. GE indicates the PV input, the voltage is too high, and on this diagram shows how to do the wiring from the PV panels to the outdoor unit. That for this error, that indicates on this string the voltage is too high. That means too many PV panels inside this string. So you need to check whether you already follow the spec, which is this upper limit 400 volt, to ensure these PV panels. If it's really too many, just lower the quantity. It's okay. If it is not, that must be something wrong with this second layer sampling PCB. You need to replace it. It's okay. So in summarize, that means the detected voltage from the PV panel exceeds the range. GJ
indicates the grid side module overheat. And where is this one? Is the first layer, the converting PCB. The detecting temperature is too high. There is from the built-in temperature sensor. So on site, what you need to do is just turn off the PC input, the AC input, and then after 10 minutes to turn on the AC power again to check whether this GJ error occurs again. If it is not, that means there is something wrong or misjudgment from the built-in temperature sensor. And if it still occurs, that means something wrong with this PCB, the detecting circuit, or this something wrong with it. So you need to change this first layer of this converting PCB. GA, too low or too high input voltage from the power grid side, which is the AC side. So for this error, first is to check the QP setting, which is the export area. And according to this, which is to select the voltage which is the same as the local power supply. If it is not, you need to change it to it is okay. If this is setting is okay, so the next is to check whether the power supply, the input voltage is in our range or not. G0, that means PV input reserve connection. That means on this graph you can find it. This is the PV panels and this is the outdoor unit. The connection, the plus and minus, they are reversed. So on site, just change the plus and minus sequence is okay to ensure plus and minus. G4, that means PV leakage current protection. If you encounter this error, here is the solution. First, turn off the AC power input and then check the this switch setting on the third CPU PCB, whether it's the same as default. And here I just make an illustration to explain this, which is first is where's the CPU PCB is at the third layer of the built-in converter, and here is the this switch, this one, to check the setting. This switch whether it's as default is 00, which is the white level at on side. Its function is to detect the PV leakage current distortion of AC input and AC output, and this is mainly caused by the PV input. And to check it if it is the same as default. If it is not, you need to change it to 00. So, and the next is to turn on the AC power again. And if this occurs within 30 seconds, that means something wrong with this first layer power converting PCB. Just replace it, it's okay. GN, that means insulation resistant protection. And here is the solution. First, turn off all the power input and then check the insulation resistance, especially on the PV input, whether it is less than 1 mega ohm. And the checking method is just use this megameter to check the PV cables. And also, if it is higher than 1 mega ohm, that is okay.
That's all for this presentation. If you still have some problems or any questions, please feel free to contact me with this email address. So thank you again and bye bye.